All right, as more individuals start to pile on in, we'll let them join us. We'll go ahead and get this show on the road. My name is TJ Kidder. I am the marketing manager here at Learn Academy, and I am pleased to introduce Kevin Gorham. He is a software engineer at Finetune and a resident of our software residency program. Welcome, and he will be talking to us about leveraging libraries in React. So I'm going to go ahead and pass the floor off to Kevin. Thank you all for joining us, and I hope you enjoy the presentation.
Thank you. Thanks for the introduction. If anyone hasn't met me, I guess you said everything I was just going to say. I was like, I have to introduce myself. But I'm Kevin. I'm a junior dev. I spent a year doing QA, and I've been in my current position since about January. And I'm talking about a couple libraries today that we're using in my current project that I'm working on at work, and I found that I'm getting a lot of utility out of them. So I wanted to share them with you all. So let's see. So this is slide 1 of 240. So we're going to move fast. I'm just kidding. There's not that many slides. This is what you're in for. So I'm going to talk kind of at a high level about why, how to pick a good library, how do we know if one's good or not, and then I'm going to jump into looking at these 4 examples in depth with some code samples that we can talk about. So the first thing is just to cover at a high level, what is a library, right? Well, since we're talking about React, first, React is a library. I'm talking about generally smaller libraries that are, they're a collection of pre-written code, and they're made available to you as packages. And in JavaScript, we use NPM. Ruby has gems, right? Every language has a way to get pre-written code integrated into your systems. You can use a CDN, you can download the library and put it right into your project. There's many different ways to go, but it's just code someone else has written that we want to use. So why might we want to do this? And essentially, if there's a problem that you're facing, especially as a junior engineer, chances are that somebody else has already solved it. And not only have they solved it, they've probably optimized it for speed and memory use, they've tested it, they've documented it, and if it's a popular library, they've probably done all those things very well. It just kind of boils down to nobody gets ahead by constantly reinventing the wheel. So if you need a function or to generate a random number between 1 and 100 in JavaScript, and you don't know off the top of your head how to do that, you copy paste that out of Stack Overflow. You don't need to work on that yourself. And libraries are that same concept, just at a higher level. So pros and cons of libraries, and this is really supports the why. And I think time saver is the biggest one, right? That's probably the most important benefit. You shouldn't spend time developing functionality that a library can provide, so you can spend your time developing like the core business logic of your application or the features that really matter. Popular libraries get used in lots of environments and in many use cases, and the feedback loop that results from this causes bugs to be reported and developers to fix them. And so you end up with these really thoroughly well-tested chunks of code, more than you could do personally. And that just ensures stability, right? So you can be pretty sure that if you're using a third-party library, it's not going to endanger the quality or stability of your application. The idea of modular code, it could probably be a tech talk in itself that I'm probably not qualified to discuss the benefits of quality code, of modular code, excuse me. But libraries, by their definition, their code is kept separate from the rest of your application's code. And you have to communicate with these libraries very clearly through that library's APIs. And this, using modular code, encourages you to write modular code, which reduces side effects and causes you to write better code. So that's one of the things, especially when we get to talking about Ramda, that the benefits of using it is it encourages you to write better code. And I wanted to point out UI libraries. That's not a pro of libraries in general, because many of them are not UI libraries, but development and design are really two different disciplines. But we are often asked to do both, especially as junior engineers or full stack engineers. If you're trying to build small project for yourself or your own portfolio, or you tell your friend you're going to build them a website for their small business. Not only do you have to develop it, but you have to design it. And if you, like me, are not as good at design, leveraging these UI libraries can give your sites a very professional, a very cohesive look. And again, it goes back to that first point of saving you a lot of time that you don't have to spend fighting CSS. So there's a couple really popular ones. I'm not talking about them today in depth, but Bootstrap and Material UI are probably the top two that I've heard the most about. And leveraging those can be really helpful, especially as a junior engineer. There are some cons to leveraging libraries. And when I say dependency, I mean, if you integrate this third-party library into your application, and for whatever reason you have to switch libraries, your code is now reliant on that. So you have to do a lot of code changes to update your project. It kind of ties into number two, which is a lack of support, in that sometimes libraries get abandoned by their authors. This happens a lot on platforms like Android, where new versions come out all the time, but all libraries eventually become deprecated because new stuff keeps coming out in this industry. So if you have a project that takes place over 8 years, for a business, chances are it's going to be using some libraries that are no longer popular. And so that's just something that, tied to dependency, over time you're going to have to phase out the old libraries and update your code, and that kind of creates tech debt. So it's something to be aware of. When I say overuse, I mean using too many libraries in one application. Sometimes, it's very rare, but occasionally 2 different libraries will not play nice with each other in the same system. And if they cause an error, it's really hard to pinpoint and debug and fix that issue, because it's not code you've written. You might not even have access to the code if they're not open source libraries, and it can be really tricky. You can't look at library A's docs or library B docs, because the issue comes from the interaction of these 2 libraries. And so that can be a big headache. And you run into that a lot with like WordPress websites and plugins, which is not technically libraries, but similar issue of these added pieces that you didn't write, having conflicts that you can't control, and they can cause a lot of headaches. And so another issue with adding libraries, or another concern, is security vulnerabilities. So if I was a malicious hacker, I wouldn't attack your personal, portfolio website. I would want to look at common libraries and find security vulnerabilities in those. And if I found a vulnerability in Ramda, for example, which gets downloaded 8 or 9 million times a week, and I find that vulnerability, now I have access to every website that uses that library. So libraries are increasingly becoming a target for hackers and malicious actors. And there was one from 2018 called Event Stream that had some malicious code in it that would steal your Bitcoin from your wallets. And it had about 2 million weekly downloads. So it's not unheard of that these things happen. So these cons do exist, but we can try to mitigate them by carefully selecting the libraries that we put in our application, which is what I'm going to talk about next. So how do we choose a library, right? These are the questions that I ask myself when looking at a library and trying to determine if I should include it in my application or not, right? And the first one is, how popular is it? On NPM, we're going to take a look at a couple examples, but you can see the weekly downloads. On GitHub, they have stars. You kind of trust the hive mind, right? If a library is downloaded 100 times a week, that would scare me a little bit, versus one that's being downloaded 5 million times a week. There's probably a reason for that. And that one's probably, safe to use. Not all documentation is created equal. Read it. Does it make sense to you? Is it written in a way that you understand? It's not too simple or too advanced. When I was in a coding bootcamp, my first project, I wanted to integrate the Google Maps API. And then I found out that there's actually about 12 APIs, and I spent all weekend reading, and I had to call senior developers to help me. And eventually we got it to work, but it was a mess, and I probably shouldn't have done it. And so the point is, pick one that makes sense to you, which goes to number 3 also, is it doesn't meet your need. There's going to be many options. There's a lot of map APIs out there, for example. I didn't need to use Google's. I might have found one that was simpler, that would have met my need, and I could have implemented it more easily. So don't just pick the first one that comes up in your search. Look around a little bit and make sure that it's really solving the problem that you're trying to solve. And the when was it last updated piece is important, because, like I said, things move fast in development, as you know. By the time you finish your bootcamp, there's probably new tech already coming out. And that happens all the time. So if a library hasn't been updated in 3 years, that's kind of a red flag that says maybe there's a new library that's doing something similar but better, or maybe I don't need this library because JavaScript has implemented the features natively, or whatever it may be. So let's take a look at Ramda. So this is one of the libraries I'm going to talk about. Here we are on NPM. If you search Ramda, this would pop up. It's got 9 million weekly downloads. So that first off is like, awesome. This is probably safe. It's probably good. 9 million people are using it. The documentation is good. I want to open up this documentation to the side because I really love Ramda's documentation. They have all their methods you can use with Ramda on the side. You click one, it gives you examples. You can expand it to have more information. Then they have little code examples. It's very clear, easy to search. The docs are great. And so that, is a big plus for me as well. Let's assume it meets our need. The last publish was 10 months ago, so not super recent, but it's still getting 9 million weekly downloads. So it could be that it just works and they've worked out the bugs. You could look at when the original release was and how many iterations there were. Ideally, you could see, a publish a week ago, so I know that they're working on it. But it's something to notice, to consider. I wouldn't not use this because it hasn't been updated for 10 months, but I would definitely notice that. Consider that when you're making your decision. Recompose is another library that's also used in the application I'm working on, but it was last published 3 years ago. It still has 1.3 million weekly downloads, so people are still using it, probably when they're cloning older projects that used it and they're installing it. It's got good documentation. What Recompose does is it adds hooks to React. And you might say, but React has hooks. Well, 3 years ago, they didn't. So this library came out, it solved a problem in React, and it was written by a developer named Andrew Clark, and React actually, or Facebook, hired him to come work for React to help write hooks. And then React released hooks, and he abandoned this project. So the documentation is good. Many of the components in the project that I'm working on use Recompose, so I reference the docs to try to understand what's going on. And as we touch different parts of our application, we refactor that code to get rid of Recompose and use hooks and some of the new features of React. So that's, back to my pros and cons. This was great. It solved the problem. Now it's causing tech debt for us. So, it's a mixed bag, just something to be aware of. Couple other things to consider, how well written is the code, which goes to if it's open source, you can see it, you can actually look at it, do a little exploring, see if it's well documented, well tested. What license does it have is important, especially if you're doing a commercial project. Some licenses are restrictive in terms of how you can use a library. Like you can't make money with it. If you're trying to charge, you can't use this open source project. Or there's many different licenses out there with different parameters in terms of how you can use it. So the MIT license is what you'll see on a lot of very popular libraries. And the MIT license basically says, we wrote it, you can use it, we're not responsible for whatever you do with it. So, go forth and conquer. So the MIT license is pretty much a free use pass. And I think the MIT license is on all the libraries that I'm going to show today. But it's something to be aware of, especially in a commercial situation. And the last thing I wanted to mention is that many platforms, many languages have a number of de facto libraries that are commonly used by the development community. And that's probably an indicator that it's a good one to use. I think that's it for kind of the, the how, the why, the what, how do we pick a good one. So I'm going to shift gears here and start taking a look at the 4 examples that I highlighted in the beginning. And the first one we're going to talk about is called class names. So class names is the simplest library that I'm going to showcase today. And what it does for you is help you conditionally join class names together. Why might we use class names? Well, one criticism I have of React versus traditional web development is that with JSX, the JavaScript markup, we're combining HTML markup and JavaScript logic into one file. Now, our browser doesn't care if the code is 1 file or 100 files, right? But we as humans like it to be split up into logical chunks so that we can more easily find what we're looking for and debug problems. And when you combine HTML and JavaScript, you're already kind of commingling responsibilities in one file. And if you add to that a bunch of additional logic for conditionally rendering CSS classes, then it just further complicates your components and can make your code harder to debug or just a little more complex. And so in an effort to simplify that, to clean up our code, we might use a library like ClassNames. And I'm going to share the link to this presentation at the end. I'm not going to go to every link on all of these tabs, but I put the NPM link to ClassNames and the docs here for you to explore. But the ClassName docs are good. So here's an example of using the ClassNames library. So ClassNames, so first in our project, we would install ClassNames with NPM. Then we would import it into our file. And we would then have access to this ClassNames function. And ClassNames is a function, you can see we're calling parentheses, that takes in an object as an argument. And what ClassNames does is it returns a string of all the keys whose values evaluate to true or to be truthy. So in this example, we're saying I'm making a variable const button class, and down here in my return, my button, I pass it as the class name for my button element. And so let's assume these are state dependent, that they're all false. My component mounts, ClassNames gets called, it gets past this object, button is the key, the value is true. So this is always going to return the string btn. And then it's going to look at button pressed. And if the state of is pressed is true, this gets added. And if the state is false or falsy, it does not get included. So this would, as written, assuming that these state values are false, would just return the string btn. And depending, as we use our app and update our state, this gets reevaluated. And if these keys values become truthy, then our class names will return a new string. So the class on our button will update. So I have an example of this here in a little code pen. And this is using React. We have a class component, and we're keeping the is pressed and is hovered state in our state, and I'm defaulting them to false. So show you the CSS real quick. We just have 3 classes for our button. We have the regular button class that gives us a green background. When we press it, we should get a blue background. And when we hover over it, we should get a red background. So these are our 3 CSS classes. And if we look back at our element, this is the class names piece I was just breaking down. I've also added here a little event listener for when we click on it to update the pressed state on the button. So if we click it, it's going to turn on and off. And I have a toggle hover function to when we hover, it's going to call this function, which is going to update our hovered state. Down here, we have our return for our button. On click, you guys are probably familiar with if you've done some React, and I pass it this handle click. On mouse enter and on mouse leave are event listeners that React gives us access to, like on click for on hover and on mouse exit, essentially. And so I pass them my functions, so they get called when they happen. And let's look at the state as it is now and extrapolate what class names is going to return. So right now, button is true. There's other ways to write this. You can actually pass class names. If you always want button, I could pass it the string of button, and it will always add button. But I wanted to, showcase this so we could, as a clear example of how these values evaluate to true or false. So because button is true, class names will always return the string button. Button pressed, this.state.isPressed is false, so we don't get added. And button over, this.state.isHovered is false, so it doesn't get added. So right now, if we were to inspect this button, we would see the class btn on it. As I hover over it with my mouse, it turns red. On hover, my on mouse enter fires. It calls toggle hover. That updates our state of is hovered to true. This gets reevaluated. Class names button is true, that's there. And then this would print button over. So class names would return that string, button over, which is how we end up with the red button over styling applied to our button. And if we click it, we update the pressed state, and our button pressed gets added to our string. So this is a pretty simple example. Obviously, I went over it quick. and my objective is not to teach you how to use class names as much as just to showcase the value of it and hope that if you do a lot of conditional styling in your app, you might think to use this app, because down here in my element, all I have is this button class variable, and class names handles all my conditional rendering for me in a very kind of clean and simple way. So if you want to handle, style links differently if they've been clicked or visited, or buttons obviously is a good use for this, or people get really creative where dynamically, changing how things look as you interact with pages. Class names is just a way to simplify that so that your JSX components can be really clear and readable. So I'm going to jump back to the slideshow and move on to the next example, but we'll have time for questions at the end. So if anybody is confused by this, jot down your questions and we'll come back to it at the end. So that's class names. It's probably the simplest library of the ones that I wanted to showcase today, but I thought it was a good introduction. And this is the next library I wanted to talk about. It's called Formic, and I shouldn't read my bullets I wrote in my slides, but I love this without the tears bit. If anyone has built a complex form in React, you'll understand that it's painful. There's a lot of repetitive and annoying stuff for keeping track of values, errors, visited fields, orchestrating validation, and handling submission and error messages. Formic will do all of that for you so that you spend less time wiring up state and change handlers and more time focusing on your business logic. Some big websites use this: Walmart, OpenTable, Airbnb, NASA, Stripe, Nokia, Sony. There's a big list of companies that use Formic. So some of the best engineering teams out there are utilizing it. And I wanted to point this out. Forms are so difficult in React that React has an article about dealing with forms. And they have this example here, which I pulled in our code pen. So we're going to take a look at their example a little in depth. But down at the bottom, I wanted to point out that for fully fledged solutions, they put a link to Formic too. So React is telling you, hey, we recommend Formic. So that's back to who recommended this library. Well, React did. And so that's a pretty big vote of confidence in my book. Move too quick. So let's take a look at the code example for this guy. And what I've done for Formic to showcase its value is I built the same form. I actually took the form out of the React article and did it as they implement it, and then I implemented it with Formic. So I'm going to comment out the Formic component and comment in the regular component, which I commented out. So this reservation component, we'll take a look at the code, is here. It's this form. You have a checkbox for if you're going or not to, say my tech talk, and the number of guests, and we can just increment or decrement the number of guests coming to our event. And so first things first, this is a pretty simple form component. There's 2 inputs and a button, and we've got more than 1 page of text already here, code, right? I've implemented or they did in the React example, a class style component. We keep the isGoing value and the number of guests in our state. We have to bind our handle input change. The React devs are great. They came up with this pretty clever little handle input change function that takes in the event and can determine the value based on the type of the target, if it's a checkbox or not. And then they use the name of the input as the key and the value as the value. So this is a pretty clever little handler that I wouldn't have written this well, I can honestly say, without a lot of work or help. And then they just render, the rest of the function is the render function where they have their on submit. And when you submit, it just alerts if you're going, and the number of guests just alerts the state for us as a string. And we have our components down here, which are pretty straightforward. So let's comment out this one, because we want to talk about Formic. And I'm commenting in the Formic form. And look, it looks very similar. I can check or uncheck my checkbox. I can increment or decrement my number of guests. And when I submit, I get my alert of the state. So taking a look at the Formic code, the first thing I notice is that it's less than 1 page. So less code is generally better for getting things done quickly. Not only that, but in this example, I've added some validation and some error handling. So if I'm not going but I have a positive number of guests, we throw an error and I can't submit. Also, if I am going, but my number of guests is 0, we get an error that says enter the number of guests and I can't submit. So with less code, I have form validation and error handling handled by Formic here. And the way this works, backing up a little bit, is of course we would install Formic via npm. On the code sandbox, you just add it as a dependency right here. So I add Formic, and then I import the pieces of Formic I want to use from Formic. And in this case, I use their form component and the Formic component. And the basic structure is you put your form inside your Formic component. So you can see down here, I close my form and I close my Formic component. Your Formic component takes your initial values. I no longer have to keep the values of my input fields in state. On a more complex form, I would write a function here called map, maybe map props to values that takes in some props and sets up all these to simplify this. But this example only has 2, so we can just list them here. On submit, I pass Formic. It has an on submit prop, and I pass it my on submit function, which just alerts for us. And then I also passed it this form validator, which takes a function. And I wrote a little function in this util that takes in our form values, and if these conditions are met, we add errors, and then it just returns the errors. So Formic is set up to accept a function that takes in values as a validator and check if it returns errors. So this is a little confusing. It was confusing for me, but the Formic component accepts a render function, which is in here. And it returns some JSX, essentially, which is this. And it gets called with the values from Formic. So we pass Formic initial values. Here, in this function, we have access to the values. So this will read the initial values, and Formic gives us this handle change. I didn't write this handle change event listener. Formic just gives us access to it. So if I check or uncheck our checkbox, or if I click up or down, you can see my form is updating. This handle change thing is updating our value automatically for us. It took me a while. When I first joined this project, I saw Formic all over, and I thought, why are they doing this? This is making it more confusing and more complex. I could just handle this in state with hooks. This example is about as simple as you can get for a form. There's 2 input fields, and we're already at less code. The current epic we've been working on is adding this giant form to the application with many checkboxes, date pickers, input fields, percentages, and doing that, implementing Formic has made me really appreciate its value and see how much it simplifies things. Not having to set up state, not having to write event handlers, having validation handled easily, having errors handled easily, comes really intuitively and easily when implementing Formic. So it can be a little confusing at first. It's definitely more complex than class names, but when building forms is a more complex job than dynamically adding or removing class names to a single component. So I don't want you to leave this tech talk saying like, great, I understand Formic 100%. I don't understand Formic 100%, but what I do want to do is just showcase, I'm trying to showcase its value so that you can appreciate that there's less code going on here. It's handling a lot of complex stuff for us very easily. And as our forms become more complex, this becomes more and more and more valuable. So I would just encourage you to perhaps next time you build a form in React, think, okay, now let me try to implement it with Formic and do that and see how much simpler it becomes and how clean your code is. And especially if you have a complex form, you'll start to really appreciate the value. It does a lot more than what I've showcased here. You can have arrays of values. If you have 20 checkboxes, it can do a lot. And I probably still only scratched the surface of it. So Formic is great for forms. You're going to do some forms, consider Formic, I guess is my TLDR for this. So again, if you have any questions, jot them down and we'll come back at the end. And I'm going to move on to the third library that I wanted to showcase for you, which is called date functions. Now, who's ever had a math problem like, Sally leaves your house at 5 p.m. and travels 800 miles, from this time zone to this time zone, and dealing with date math is just more confusing, especially when you get into 3 weeks ago. And if you want a month ago, but you're on the 31st, do you go to the 30th? Did the previous month have how many days were in the previous month? If you've ever had to deal with date math, I don't have to sell you on that it's confusing. And these are some of the key values of the date functions library. I18N, in case you're not familiar with it, is a international syntax. So you can pass the date functions an argument to tell it what language you want the output to be in, and it will spit it out in that language. And then your application might detect a user's location and find the country and update the language based on that. And date functions would still work, and all your output would come out in the language of your choosing. So that's a nice little bonus I wanted to point out. But great docs, simple, all of these things I don't need to reiterate. Date functions is a cool little library. So here's a couple examples out of the date functions docs I wanted to highlight just to give you a high level understanding of how it works. We're importing, these 4 methods from our date functions library. Assume we installed it in our project with, npm install date functions, and we want to use it. And so if you want to print out a string like today is Friday, but you have a date object, so saying new date in JavaScript will return the current time and day right now. So, that would be what 12:37 on today's date is what this would return. But with a whole bunch of other data, the JavaScript date object is pretty verbose. And so having to parse through that and change that object into the string Friday would be a lot harder if you didn't have this format function. So this format function takes in 2 arguments, a date, and this is really the other argument, the EEEE. And that says, print me out the day. I'll show you another instance of using format in the code pen in a minute here, but all they've done here is concatenate today is a to that. And so we print today is a Friday. Format distance is slightly more complex. It takes in 2 dates, and this 3rd argument is optional, and we say add suffix true. So format distance is telling us the distance between 2 days. And when we say add suffix, that gives us the days ago piece of this. So we're passing it 2 dates. This first one is slightly more complex because we're using the subdays function from date functions. So we're saying, take today's date right now and subtract 3 days. So our first date is, Friday, Thursday, Wednesday, Tuesday. It would have been Tuesday. And then today. So it says, what's the distance between 3 days ago and today? And spell it out for me, and we get 3 days ago. Format relative works similarly, but it gives you a different string. We get the relative distance, essentially. So we get last Friday at this time. And if you wanted to, you could probably pass this more arguments to determine what kind of string you want returned. So if you wanted to tell your user you last visited our website 3 days ago and you had a timestamp in your database, format distance would be a great way to just parse that into a nice legible string in an easy way. So you didn't have to do all that math and stuff. Now, these are relatively simple examples. In that giant form I was discussing building with Formic, one of our inputs is an input field, a date picker. And the business wanted the date picker to default to the last Friday of the previous month, which, as the business, they say it should always be the last Friday of the previous month. And as a developer, I said, okay, right? I know that's doable, but I wasn't really looking forward to writing that function. So we used date functions library to help with this. And I'm going to show you a few implementations of this, actually 3, and they get better. So this is the worst one. So the first implementation of this, here's our component. It's just a heading that says the last Friday of the previous month was, and then we're passing in this variable last Friday of the month. Now try quickly to parse through what's happening here. It's a little confusing, right? JavaScript gets evaluated inside out. So we're saying, take a new date now. So right now, and we're passing in a second argument 1, and we're giving that to subtract months. So subtract 1 month from today, and then last day of month gives you the last day of a month. Go figure. Well named. And so we go back 1 month, we get the last day of that month, and then we find the last Friday. And I had to write a little recursive function to do this. There's probably many ways to do this, but this is the solution I came up with. And then we format it. And I pass format the string I want it as year, month, day, which is what we end up printing out over here. Define last Friday function is using the isFriday method from date functions. It just returns true or false if the date you pass it is Friday. So the way this works is, we get a day, we get the last day of the month, we pass that in as the date argument, we check if it's Friday. If it is, we just return that day. Otherwise, we call the function again, subtracting a day from the date we checked. So it recursively calls itself. So if it was Sunday, Sunday is not Friday. We don't return the date. We call the function again and we subtract a day. So we pass find last Friday, Saturday, not Friday, gets called again. The third date is Friday, so we return that date. And then we pass that to format and we print it out here, or in my case, it was in a date picker. So this is not a lot of code to do a pretty complex calculation. Without the date functions library, I don't even know. I probably couldn't have determined this without the use of a library. And if I did, it would have been much, much more code. But this is not a great implementation because it's not that parsable as a human, right? It took me a lot to explain that and articulate that. And some of you are probably still confused, or I would be if this was the first time I had seen this. So we can improve upon it by writing it out a little more. This example is a little more verbose, but it's more parsable as a human. So this last Friday of the month, now what we see is we're saying format date and we're passing it this date. And we can see, okay, we start with the previous month, we get the last day of the month, and then we find the preceding Friday. So I've just basically broken up those into my own functions up here that call the sub months, the sub days, the format, so that this function, I'm sacrificing keystrokes in order for my code to be more readable. And oh no, sorry, my screens just went off for a sec, but they're back, or one of them's back. Can I get a thumbs up? You guys can see still? Sorry, apologize for that. I don't know why my screens went off. So code golf is something we do to impress other developers, right? Look at this complex thing I can do in 10 keystrokes, but in real world situations, we don't want to play code golf. We don't want to sacrifice readability and parsability for fewer strokes, right? Name your variables what they are instead of X, right? X would be quicker, but if I have to come debug your code and your variables are named X and Y and Z, I'm going to be cursing you long after you leave that job. So this implementation looks like I deleted the function, yeah, somehow. This implementation is a little more verbose, but I think it makes it a little more readable, right? So I think this is a slightly better example, but we can still improve upon this. And I'm going to use the last library that I wanted to talk about today to do that. So I'm going to leave this and we're going to come back to it. The last library I wanted to highlight today is called Ramda. Now, Ramda is certainly the most complex of these libraries. It was very confusing for me. It's still very confusing for me. The value of Ramda is hard to articulate. I'm going to try my best to highlight its value. But what is Ramda? Ramda is a library specifically designed to utilize and promote a functional programming style. JavaScript is kind of a mix between functional programming and object-oriented programming. It was more functional when it came out, but it has rules about inheritance that follow a object-oriented programming language paradigm. And you might not see in your jobs, in many jobs, any functional programming. They might take an object-oriented approach. They might just not use functional programming, but functional programming is really cool. And again, it's probably beyond the scope of this tech talk to talk about why, but it boils down to immutability and side effect-free functions. So It can also be faster. With object-oriented programming, you have these big class objects that have a lot of data in them, versus in functional programming, you give it an input and you get an output. And it doesn't have to know about what anything else does because its job is very simple. If you're working on a project, or if you just want to try to write functional code, utilizing the Ramda library in your application will help improve your code and make you write better code. And so not all libraries are just about rendering things. And Ramda can be used outside of React. I should mention that most of these, I guess except Formik, can be used outside of React. But they kind of, they shine and you can use them in React. But you could use Ramda in any application using JavaScript. So I put some links here to some good articles about using Ramda, why to use it, some of the benefits, and why about currying functions and why currying helps, how to approach problem solving in Ramda. But I'm gonna take a look at our date function example and try to do a little live coding here, and we're gonna Ramdify this component and see if I can showcase the benefit of implementing Ramda. So here I'm looking at my Ramda app right here. So in my index, I'm going to go ahead and comment out my app and comment in the Ramda component. Looks like it's busted. That's okay. We're going to change it anyway. It's called the better app because I copy pasted. This we call the Ramda app. Okay, cool. So we got our component. Now this is exactly what I just previously showed you. And we're going to use Ramda. So I've already added it as a dependency. I'm going to import it into this file. So I'm going to import. And the piece of Ramda I want to use is called pipe. So I'm going to import a pipe from Ramda. And I'm going to talk about what that does. And what we're going to do first is refactor this function to use our pipe, our Ramda pipe. So I'm going to just add an X here rather than delete it so we can reference it. And I'm going to define a new variable called last Friday of last month. And we're going to set this equal to using pipe. So we're going to say pipe. And pipe takes in a series of functions and an argument. And the way pipe works is it passes our argument to the first function, and what that returns gets passed to the second function, and what that returns gets passed to the third function. And you can pipe 50 functions if you wanted to. So in this function we're refactoring here, our argument that gets passed in is the previous month. So we're going to take that, we're going to pass that in as our argument. And the first function that gets called is last day of the month. So we take our previous month and we get the last day of the month. And then we find the preceding Friday. And then we format the date. And our component works. So I would probably structure this a little differently. Let's see if, yeah, the autosave does that for us. So now when we go to parse and read this function, we can see, okay, last Friday of the month calls, it takes in a date or the previous month and gets the last day of the month. It finds the preceding Friday and it formats the date. That's pretty cool. I think this is a cleaner implementation than what we previously had. It's easier to kind of parse and read what's going on, but we can take it a little further. These variables don't rely on state, so they really don't need to be in this component at all. So I'm going to cut them and paste them up here as just kind of global variables. This last Friday of the month can also get pulled out. And instead of passing it previous month, you don't have to pass functions in Ramda their final argument. And if you don't, last Friday of the month will return, pipe will return this function waiting for an argument. So down here, instead of passing it this variable, I pass it as a function, and then I'll now pass it previous month. And once it gets past its argument, it will execute these three things. And our final component can look like this. And since we're just returning, we can get rid of our return statement also and curly braces. And now our final component looks like this. And if you wanted to take it one step further, you could take all these helper functions and make a utility file and throw them in there like I did with the form validation in the Formik example. So when you came to our Ramda app function, which is not a great name, you could just see this. And if you wanted to know how this was being calculated, you could go to your util and dig into that. So this is a much cleaner implementation than this, in my opinion. And again, Ramda, it's hard for me to articulate, probably because of my own limitations, the benefits of functional programming and implementing Ramda in your application, but it will encourage you to write in this functional programming style. You'll write really clean code, and it'll help you grow as a developer. There's a lot of other Ramda methods. There's things like is nil, which is a cool check, right? If you're doing a conditional where if something is false or is nil or falsy, like most of the time we don't write it out like this. Developers will get rid of that and just use our bang. So if not something is confusing. Ruby gives us unless. You can say unless instead of if, but if we're using Ramda, we could pass it is nil or something. And then this is easier to read. If something is nil, do this. And that is easier for us logically to follow. So they have a lot of checks like is nil, is empty. They have methods for combining objects, for merging. They have a lot of array methods. There's lots of libraries out there. There's a lot of similar methods in a library called Lodash, which is very popular, but it doesn't take as strict of a functional programming approach. So I wanted to highlight Ramda because I think functional programming is pretty cool and worth digging into. And also because I wanted to learn more about it in setting up for this tech talk. So that's it for my code examples highlighting. I think that brings us pretty much to the end of my talk here. In conclusion, why do we use libraries? All these reasons. And it comes down to we want to make more money. If you want to impress your bosses and get stuff done quickly, or if you say, I'm going to build my friend a website for $500, if you do that in 10 hours or 50 hours, you still make your $500, right? So doing it faster, better, cleaner is only going to help. Yeah, well, that's it. I went a little longer than I intended to, but looks like we have a few minutes for questions. So if anybody has questions, feel free to either put them in the chat or just say them, or no big deal.
Well, thank you so much, Kevin. That was a fantastic presentation. Anybody who has some questions, you do have the ability to unmute yourself. So just go ahead, and if you have any questions, please go ahead and ask away.
Kevin, that was awesome. Nice job. And so I know you mentioned you were pursuing these particular libraries because you guys were implementing some of them in your project at Finetune. Are you using all of them?
We are,
okay.
and more. React Use is one that I almost put in here. It like adds a bunch of hooks that you can use. If anybody wants to check out React Use, I felt like that and Ramda were the most complex ones, and I trying to keep it to an hour, I omitted that one, but we get a lot of use out of those. And with all of these, I was confused by them at first, and I'm, I don't know how many months in, 5 months in now, I'm starting to really like them. So if you watch this today and you're like, that's confusing, I'll do it in state, I don't blame you. I thought the exact same thing. I just encourage you to give them a shot. And as you get more comfortable with them, I think you'll find there's value there.
I actually didn't realize that class name is a library just because you use it in JSX like out of the box in React. And I didn't realize that. That was really interesting to me as well.
Well, so it's not, right? Class name, because class is a reserved word in JavaScript, in JSX, when you want to put a class on an element, you have to say class name. Class names, plural, is the library named after that piece. So
okay.
You still need to install it and import it.
Oh my gosh, okay, I got it. I missed that part. Cool.
Yeah.
Kevin, we had a question from Elise in the chat. She was wondering if Formic works well with functional components as well.
It does, and I think I actually, oh, I didn't mean to go there. I think in my example, the React example was a class component, but when I redid it with Formic, I think I made it a functional component, or I intended to. Let me double check. But yeah, so I'm using a functional component here with Formic and Form. And in our project, we pretty much only use functional components. We've pretty much gotten away from using class components. I'm okay with no questions too, because that hopefully means I explained it well, or people are sleeping. So either way, you know, it's lunchtime. Have a big sandwich. I'm not blaming anyone.
Well, like I mentioned, we also recorded this presentation. We're posting it on YouTube by early next week. So if you did miss the first half, you are in luck. We have you covered. So if that finishes up all of our questions, last call. Thank you all for joining us. It was a great presentation. Kevin, that was wonderful. And we're looking forward to getting our next connected sessions up on the calendar. So keep an eye out and follow us on Meetup and Eventbrite, and we'll let you guys know when the next one's up and out. So thank you, everyone. It was a great presentation, and happy Friday. I hope everyone has a good weekend.